Hey class, this week we are going to be learning about operators, precedents, and control structures. So with operators in C++, it's very similar to most other programming languages. This is the greater than sign, less than. Compare equals would be like something in an if statement. Does this equal this? Not equal, use the exclamation point or the bang operator, and if you put that before the equal sign, that will say that'll compare if they're not equal to each other. Then you have the greater than or equal to sign and the less than or equal to. The two that may be a little less intuitive are the and the or. So if you're comparing multiple conditions at once, you can be check this condition and check that condition. You'd use the two ampersand signs. If you're doing an or, you'd use the two vertical bar signs. That's the bulk of the operators. Like I said, most of them are pretty intuitive. I would say the and the or are maybe the weirdest. And then the comparative ones, if you're not used to that. Okay, so as far as precedence goes, what that means is when a program is executed, what takes the highest priority? What is executed first, right? You can kind of think of it as order of operations. So the very first thing that will always be calculated first are these signs. So the exclamation point, this bang operator, means not, right? So if you had a Boolean variable that was equal to true, and then you put the exclamation point before it, that would be saying if not true, right? The two minus signs, remember that is a decrement operator, so you're subtracting from itself. And then the two plus signs is an increment, so it adds. So that's going to take the highest priority. Next, you're going to take the arithmetic. So, I mean, we learned this pretty early in math in elementary school. You're going to take the multiplication, the division, then the modulus, which is a form of division. And then after that, from left to right, then it goes into adding and subtracting from left to right. After that, it's relational. So the greater than, less than, greater than or equal to, less than or equal to. Then the comparative equal to or the comparative not equal to. And remember, these go left to right. So in this case, it's going to check the greater than before the less than, so forth. Logical, so the two ampersands, the and operator, and then the or operator, and then the assignment. So this would be x equals 4, plus equals, right? X equals x plus 4, minus equal, times equal, divided equal, modulus equal. Okay, as far as statements go, there are two types. You have the break and the continue. I will get into this a little bit more later in the PowerPoint, but a break statement causes you to break out of a loop and to check that condition again. And then a continue statement does the same thing, but it just skips the rest of the code in that loop. And then it goes back and does checks the condition again. So a control structure is going to be our loops and our if statements. So you have a for loop, a while loop, and a do while loop. And then for our if statements, you have an if else, and a switch statement. So with control structures, there are three main types. You have the sequential procedural ones, conditional, and iterative. So looking at the sequential and procedural structures, that is just normal code. You do one line after the next. So this is some C++ code. We have our preprocessing directive up here, the include IOStream, using namespace standard. And then we have our main driver function. And then we're printing to the console. Let's learn about control structures. Then we're assigning a variable, int num equals 1. The number is 1. This is sequential. Each line is executed after the next, right? Okay, for conditional, that's when we start talking about if-else statements, and switch statements. So this is where code can kind of branch off a little bit, and different pieces of code can be executed depending on what the values are. So if you look at this left screenshot, this would be our if and if-else statement. So up here is all sequential. And then when we get down to here, this is where we have an if statement. Now the syntax of an if statement in C++ is a little odd. Things are kept within these curly brackets. So you'd write if, and then within the parentheses here is where you'd put your condition. So this says if num is greater than 5. Then you would put what it would execute if that was true. So if num is greater than 5, then print to the console the number is greater than 5. Else, print the number is less than or equal to 5. So an else statement is an alternative. If the condition is not met, then execute this. Right? And we know what to execute because it is within the curly brackets. So in this case, let's say it is greater than 5. You'd put the number is greater than 5. Then the else statement would not execute. And then outside of this control statement, we're going back to sequential, right? So regardless of what executes here, once we fall out of the if statement, we will execute this regardless. So that is an if statement. Now let's look at an if-else statement that has another condition to it. So the code is structured pretty much the same, except here it says if num is equal to 1, then print the number is 1. Notice this else has another if statement attached. This is adding another condition. So assume that the num is not equal to 1. You would fall into this, and it would check, is num equal to 2? If it is, it will execute this. If it's not, it will go to the next line. And you can imagine you can have an else if. You can have as many as you want. And then finally at the end, if you put a default else statement, it will fall into this if all else fails. Okay. So the next thing is a switch statement. Now that is very similar to an if-else statement. It's actually the same thing. Switch statements just have a little bit simpler syntax. So if you have something that has a lot of conditions, you will probably want to use a switch statement. If it's just 1 or 2, maybe 3 conditions, you could probably get away with just using an else if. But I strongly recommend that if you have more than that, to think about using a switch statement. But functionally, it's the same thing. So let's see if I can zoom in a little bit. So this is our code again. Instead of putting an if here, you would put switch. And then within the parentheses, you do not put a condition, you just put the variable that you want to observe. Right? So if we want to observe num, we just put num here. We can't put num if num is equal to 4 or not equal to 7. We just put num. This is what we're going to observe. Then right here is we put our different cases. So case 1 is essentially saying if num is equal to 1. And then you don't put curly braces here. You just put a colon. And then you would put your statement. And then it's very important to put break here. So remember, a break statement will break you out of the control structure and evaluate it again. So here, if num is equal to 1, put you enter 1, and then break out of the whole thing. Case 2, this is like saying if num is equal to 2. If it is, print you entered 2, and then break out of the control statement. And you can go do this all the way down until you have a default statement. This is like putting your else. If all else fails, our default case is going to say this. You didn't follow the instructions. And then once again, you'll need to break out of the control statement. So those were conditional. Now we're going to learn about iterative structures. This, namely, would be loops. So as long as a condition is met, we are going to keep repeating that same block of code. And in C++, you have while loops and do-a-while loops. If you're familiar with Python, you'll know what a while loop is, but a do-while might be a little bit different because Python does not have a do-while. Let's see. And then a for loop, which Python does also have, which is also iterative. So first with for loops, the screenshot on the left is an example of what you would have to do if you did not use a loop. So notice that I have to write the same code multiple times. So I put, let's learn about control structures, int num equals 1. Then I have to print the number is 1. Then I added it, and then I put the number is 2. Then I added it, and then I put the number is 3. And notice that it's a little redundant. I have to keep repeating the same line of code. And we as programmers are generally pretty lazy and like to automate things where we can. So my rule of thumb is if I have to repeat it more than twice, then it's probably worth automating. So in this case, if you have to repeat the same line of code multiple times, you should probably think about refactoring it into some sort of loop. So the screenshot on the right is the same thing essentially, except I am introducing a for loop. Now, a for loop, the syntax in C++ is a little confusing at first, but it's actually really nice once you look at it. So you first write the keyword for, and then in the parentheses, there are 3 parameters which you have to pass. The first would be declaring your variable. This is your counter. This is what the for loop uses to evaluate its condition each time it runs. Now you always have to declare the variable here, and that variable only lives within the scope of the for loop. So int num is declared here in the for loop, and once this control statement is over, the memory will be deallocated and put back into the heap, and you will no longer have access to this variable. So it's very important to understand the scope and that num is only alive within this for loop. So the first parameter is declaring it. Int num equals 1. Put your semicolon, and then you have to put your second parameter. This is your condition. So as long as num is less than or equal to 3, we're going to keep repeating this logic. And then our semicolon. And this third parameter is how we're going to increment num. Because if we don't ever increment num, it will be an infinite loop. Num will always be 1, and so this will always just keep repeating, which is not good. We don't want that to happen. So you need to remember to increment it in some way. It doesn't have to be adding each time. I've seen people subtract, I've seen people multiply, or maybe even add by 2. As long as you do something, though, to change the value of num. I will say num++ is the most common, though. So within these curly braces, this is the contents of the loop, and all I'm putting is the number is, and then the num variable. So the best way to walk through this is if we think about it line by line. So num is equal to 1. Is 1 less than or equal than 3? Yes. Then this num++, this will happen after it's executed. So it's important to remember that num is still 1 right now. So see out, the number is 1. All right, now that we've finished the loop, it's going to go back up and evaluate it again. Now num has already been declared, so it's going to ignore that, and it's just going to go here. And now it has incremented now. So 2. Is 2 less than or equal than 3? Yes, it is. So we'll run the loop again. The number is 2. Now it's going to come back up. It's going to increment. We're not going to declare it because that's already happened. So now 3. Is 3 less than or equal than 3? Yes, it is. So it's going to print the number is 3. Then it's going to finish the loop. It's going to increment to 4, and it's going to look at it again. Is num less than or equal to 4? It is not. So since it's not equal to this, it's just going to break out of the loop. So essentially, it's executing the same thing as what was executing here. It's just less code, which is what we want, right? Okay, while loops and do while loops. A while loop is similar to a for loop, except it's not iterating each time. It keeps repeating that block of code as long as that condition is true. So here, I do some sequential procedural programming, and then right here, I put while, and then in the parentheses, I put the condition, num, and then remember this bang equals means not equal to. So while num is not equal to 0, we are going to keep repeating this. So enter a number. If I type in any number that's not 0, it's going to say the number is, and it's going to print it. Then it's going to come back up here and evaluate it again. If it's not 0, it's going to execute. And this will keep happening until the user types 0. Then it will come back up. Is 0 not equal to 0? No. So it's going to break out. So while loops, you have to be extra careful to make sure that within the loop, you are always updating that condition. You're always updating that variable. If you forget to do that, then you're going to be in an infinite loop again. So in this case, the cn is fine because the user can always type in 0 to break out of it. So on this right screenshot, a do while loop is very similar, except you write do before. This is really cool because this executes the code. It guarantees one execution before it checks the condition. So let me explain it by going back over here. If when I declared int num, if I put equals 0, then this loop wouldn't ever be executed. It would look at the condition, it would see that it's 0 and just skip it. This whole loop would be skipped. But back over here on the right, if I put int num equals 0, it's going to execute the code one time, then it's going to read the condition, and then if it's 0, it'll break out. So if you're ever in a situation where you want to guarantee a first run, then you want to do a do while. If you're in a situation where you want to check the condition before running it, then you want to do a while loop. So they're very similar, and both are really useful. Okay, break statement. Already explained it a little bit, but that causes you to exit the switch statement or the loop, and it exits the one set of brackets. So if we go back up to our switch statement, by putting break here, I'm saying I'm done with this loop. Let's break out of it. Let's be done. If you're to put continue, you would skip the rest of it, but you would go back up and check the condition again. So if you push continue, or if you type continue, it's just going to skip the rest, evaluate the condition again. If you type in break, it's just going to break out of the loop entirely. Yep. Okay, that is it as far as material this week. Not a lot of new stuff, so hopefully it's a little bit of a break for you guys. But it can get a little confusing. The homework this week is writing a rock paper scissors game with a few added elements, and you can use either an if else statement or a switch statement. That's your choice, but it can get really confusing, especially when you're nestling these statements. It's not hard. It's not like you're doing calculus. But it can be, you can kind of get mixed up pretty easily if you don't have good formatting of your code. So if you need help, reach out to me. I'm happy to help you guys in any way. And that wraps it up. Thanks.